going to talk about meteorites today. It's very narrow talk about them because our club got this, you can see that, a Meteorite Exploration Kit. So just going to talk about a few of the things that it came with. So about 100 tons of space stuff fall on Earth every day, and these range from just little specks of dust that can slowly make their way through the atmosphere to, with no harm being done to them or anybody, to larger pieces that can produce bright fireballs. The vast majority of this 100 tons are micrometeorites, just those little teeny dust specks. Just a, let's get back to there. The slideshow is not working. There we go. Okay. Just a little terminology that we might hear but not quite understand. First is an asteroid. So they are small, rocky, iron, or icy debris flying in space, and usually from about 1 meter to hundreds of kilometers across. Moving down to a smaller thing, we have meteoroids, which are, just want to get rid of this. There we go. Meteoroids, which are you seeing the faces over top?
Yeah, we can see that with the box. It says meteoroid.
Okay, you can see all that. Okay,
yep,
perfect.
Yep.
So meteoroids are micron size, so little specks to about 1 meter in diameter. We have meteors, which are also called falling stars or shooting stars. And this is actually the light emitted from a meteoroid or an asteroid as it enters the atmosphere. We can have fireballs, which are bright meteors, and so they would be as bright as Venus. Venus is the 3rd brightest object in the sky after the sun and the moon. Larger ones can be called bolides, and so this is the light emitted from a large meteor or asteroid as it explodes in the atmosphere. Meteor showers, of course, we have about, these are annual events when the Earth passes through regions where dust left by meteors or comets lie in the orbit. We have about 17 major showers during the year. The most famous one, of course, is the Perseids on August 12th. This is usually the best one. It's also nice and warm, so you could just lie out on your grass looking up. This year, I believe the moon's going to be a bit of a problem, so we'll only be seeing the brightest of those. We can also have meteorites. So everything we've talked about is up in space, and now we're getting down to the Earth. So a meteorite is a fragment of a meteoroid or an asteroid that actually survives the passage through the atmosphere and hits the ground. And this can be from a few grams to several dozens of tons. And of course, we can have comets too, which are a solid body made of ice, rock, dust, and frozen gases. As they fracture and disintegrate, some comets leave a trail of solid debris. This is where most of our meteor showers come from, is that trail of debris left by comets. Comets, basically 2 parts. They have a nucleus, which is the smallest part, or the solid part, and that could be tens of kilometers across. And the tail can be millions of kilometers long. So so those are kind of the terms we're going to be using. Meteorite classification, it turns out that anybody who ever studied meteorites on Earth has their very own classifications, and there's very little connectivity or overlap between them, including the one that came with our meteorite kit. and it's classifying things in 3 different ways, kind of on a music genre. So first we have the classic rock, and these are these meteorites have almost no metals. They are the most common ones found in space, but they are actually tough to find on Earth because they look just like Earth rocks. They're usually only found if people see them fall and know what area they are. And that's where I mentioned before, where the ice-covered deserts of Antarctica and the vast sand dunes of Northwest Africa make a perfect hunting grounds because of these lack of rocks in these areas. And as we learned last week, Chelyabinsk is a stone meteorite. Next classification is heavy metals. And these are iron meteorites, and they make up less than 10% of the space rocks, but they are very easy to identify on Earth because they are found in regions where there are no other iron-bearing minerals. And they be found by using metal detectors. These come from the cores of asteroids. So an asteroid has built up through its gravitational pull. It has transferred that gravitational energy into thermal energy. It's heating up and it starts differentiating. So the heavy elements like iron go to the core, and then lighter elements in the mantle. So the heavy metals are actually from the core of an asteroid. We'll be looking at 3 of them: Campo del Cielo, the Sikhote Alin, and the Gibeon meteorites. And their 3rd classification is the rock metal fusion. This is the rarest class of meteorites. They are stony iron, so they have both irons and those stones, kind of the last 2 classifications together in one. And they form at the interface of the asteroid's metallic core and rocky mantle. They only make up about 1% of the meteoroids in space and on Earth. And they're very easy to identify once you've found them because nothing on Earth looks like these type of meteorites. So let's have a look at some of the meteorites in this case, in this kit. The first one is the Campo del Cielo.
Colleen, can I ask you a question?
Sure.
Yeah, with the classic rock, now, are those ones also magnetic?
We are going through that right now.
Okay. Sorry.
No problem, no problem. Yes, I have a little magnet that I will be testing some of these types. So the Campo del Cielo, it's an iron meteorite. There's just a couple pictures, and I've got the actual specimen right here. About 93% iron. It was found in South America. So here we have South America in the Argentine country of Argentina. It probably fell between 4,000 and 5,000 years ago, and was certainly known by the indigenous cultures there by 1576. Its total known weight is over 100 tons. And here's a couple of the larger pieces that were found. We have this one, Otumpa, which is just under a ton. And here we have one, Las Viboras, which is just over 3 tons. And being iron, here it is, and very strong attraction to a magnet. Moving on to the Chelyabinsk, which we learned about last year. It was about 20 meters in diameter. It came into the atmosphere at a speed of 19 kilometers per second, which translates to 65,000 kilometers per hour. And it's the damage caused by meteorites and comets hitting the Earth. It's because of the speed that they hit the Earth. We can see here it split as it was coming through. So as it was heating up, it was exploding in our atmosphere. It is a stone meteorite. Fell in February 15th, 2013. Its total mass is between 12,000 and 13,000 tons. Because it was so heavily pictured by the dash cams, its trajectory is very well known. And here's a map of Russia, and we can see the path of the meteorite. These are just some of the boundaries. So somewhere in between here is where it fell and then blew up over Chelyabinsk. And we heard that one of the larger pieces actually fell into, sorry, get back there, fell into into a lake, so a beautiful round impact there. And here's the piece that fell. It weighed about half a ton. That was the largest part that was discovered. And I just have, as that picture shows, just a little teeny tiny piece of that. And being stone, I don't expect it to be magnetic, and indeed there's no magnetic pull on that. It also comes with one called Northwest Africa 869. It comes with both a kind of a pebble of it and a slice of it. This one was also a stone one found in Northwest Africa. It was found in 2000. Total known weight between 2 and 4 tons. So being a stone, there's just a little bit of magnetism in it. So a little bit of iron in that meteorite. So it came with both that chunk that you saw and a nice little slice. And this is done to all the meteorites. They take off little slices, and then they can look at the internal structure, and it helps them better classify what's in there. And again, just a little bit of magnetic pull. It's not holding on very tightly. There are also some features on Earth due to impacts. One is the Azores area. This is in Spain. Here we have Spain here. It's roughly circular, about 30 kilometers in diameter. And within that 30 kilometers, the inner area is showing impact structures. It's thought this formed between 32 and 40 million years ago. And similar structures around this area kind of point to multiple meteorite hits, maybe a string of impactors. If you remember 1994, that string of comets that hit Jupiter one after the other. So it could have been something like this. A comet or an asteroid got too close to Earth, broke up, and was a string that came down in closely spaced hits. And here's that little piece that we have. So I've just got pictures across the top there of all the different types. And being terrestrial, mantle, top crust area, no magnetism at all. The other impact one that we have is called an endokyanite. So it's also just a little piece, kind of looks meteoritic, but it is in fact a piece of glass. It's a tektite, which are gravel-sized bodies of glass. They could be black or green, brown or gray, and they are formed from terrestrial debris that when a meteorite hits, terrestrial debris is heated to a lava-like consistency, thrown up into the air, and cools then into glass. This one in particular is an endokyanite, so it comes from the Indo-Chinese peninsula, and it is thought to have solidified. So the meteor that hit Earth happened 700,000 years ago. A little piece of glass. And being glass, also not magnetic at all. So those are all the ones that came in the kit. They also have a couple what they call meteor rungs, just rocks and pumice, things that you might think are meteors, but just for a comparison that they are actually not. So I have a few in my collection. This is my favoriteest one, possibly. It's a necklace that my daughters gave me. So it's a fair size chunk of the Tektite meteorite. Again, it is iron nickel, about 93% iron. It fell in the Tektite Mountains, which is over here in eastern Russia. And the fall was witnessed on February 12th, 1947. Observers saw a fireball brighter than the sun and had a 16-kilometer smoke trail, so similar to that Chelyabinsk one. And they actually heard a deafening roar and possibly 2 sonic booms. It broke up several kilometers above the Earth and just rained a series of these small pieces. And being iron, it is very magnetic. So it's stuck on there very, very strongly. That sounds weird, but anyway. I also have another small iron meteorite from Gibeon. This is from the South Africa area of Namibia is where it fell. It's just a little piece that has been, a little slice that has been preserved in a little blue star. Of course, I couldn't resist that. It was found in 1838, but probably fell eons ago. Its total known weight is about 26 tons. And the interesting thing about this meteorite is that it has this beautiful Widmanstätten pattern. Widmanstätten was the fellow who first described this pattern, although there is evidence that it was already known about 4 years before him. So these are crystals of iron and nickel, and they only grow to these kind of lengths of several centimeters when that solid metal cools down at an exceptionally slow rate. That's actually over several millions of years. So this is nothing that we would find on the surface of the Earth. So if you find a meteorite that has this type of, this beautiful Widmanstätten pattern, it's proof that it's extraterrestrial. And even through the resin, it strongly attracts that magnet. I also have a moon rock from the Dar El Ghani 400 meteor fall. Happened in Libya. So again, we're in northern Africa on sand dunes, easy to spot things. Here's the piece that fell. You can see it looks quite odd compared with the other rocks on that desert area. So this one came from the moon. It was found in March 10th, 1998, part of about a 1.5 kilogram lunar meteorite. So there have been lots of lunar meteorites, well, suspected lunar meteorites found on Earth, but they weren't verified until the Apollo missions brought back rocks from the moon and could be compared. And this is the sample. It's only 11 milligrams, just a tiny, tiny little bit of the moon. Yeah, my last one that I have is a Mars rock from the Thyssen in Morocco. I'll give you a close look at that. So that's 7 milligrams of this. It was, the total known weight of this was between 12 and 15 kilograms. This meteorite was probably ejected from Mars about 700,000 years ago. And it was part of a shower of Martian meteorites that fell to the Earth in East Morocco. So again, northwestern Africa in the country of Morocco on July 8th, 2011. This is only the 5th Martian meteorite fall that people have witnessed falling to Earth. And this one's very interesting because it displays evidence of water weathering, and there are signs of elements being carried into the cracks in the rocks by water, which is something that none of the other Martian meteorites on Earth have shown. And again, the cosmic ray dating exposure also dates it to about 700,000 years ago.
Colleen,
Yes,
what would cause a Martian rock to be ejected? Would there be a meteor or an impact on Mars that would
exactly.
send that stuff out into space? So,
Yeah, exactly. And I'll go into that a little bit more with my very last meteorite that I'll talk about. And I just, so this is what makes these Martian meteorites. They also, any meteorite is, I showed you a big slice of it, so you can look at the internal structure, but they also do polarized lighting. So they cut a very, very thin layer of the meteorite, put it in a microscope and send polarized light through. So like sunglasses, polarized light, only the waves are only sent in one direction. So, and then you can start twisting this little rock sample under the microscope and seeing how these little crystals will affect the polarized light. And that's an identifier for any of the types of rocks, meteorites that have been found. So this shows you why Antarctica is really a good place to find a meteorite. They have meteorite searches every year. So very, very easy to find. So this would have been not necessarily a fresh fall. It could have been a long time ago, but the weathering of the glaciers, the movement of the glaciers exposes new ones every year. So the most controversial of all the meteorites that have been found on Earth is one from the Allen Hills area of Antarctica called ALH 84001. ALH refers to the Allen Hills. 84, it was found in 1984, and this was the very first specimen of that search that happened that day. It's a fragment of a Martian meteorite found December 27th, 1984. The total weight is just under 2 kilograms. Now, this is so interesting. Well, it's thought to be one of the oldest Martian meteorites found on Earth, proposed to have crystallized from a molten state rock just over 4 billion years ago. Based on chemical analysis, it is thought to have originated on Mars during a period where liquid water existed on the surface. And in 1996, a group of scientists claimed to have found evidence for microscopic fossils of bacteria inside this meteorite, suggesting that these organisms may have originated in Mars. The claim was immediately made, worldwide, this big announcement. Very, very controversial, and pretty much now has been the wider scientific community has really rejected this hypothesis because these things can be explained without biotic life making them along other ways. However, if you talk to all the scientists who have studied this rock, 50% say yes, it's absolute signs of life on Mars, and 50% will say absolutely not. There are other things that could have done this. So this probably left Mars when a different meteor hit Mars about 17 million years ago, and it fell to Earth about 13,000 years ago. So it spent about 17 million years getting from Mars to Earth. There also are other rocks that have similar things, but none of them have come from this kind of wet area of Mars. So that's why this one is of such interest, because we've already talked about how important water is to life. And so in April 2020, no, that's not true. In 1996, this picture was taken under an scanning electron microscope, and that they thought this structure looked bacterial-like. However, This structure is only between 20 and 100 nanometers, a nanometer being 1/1000th of a meter, which is much, 10 to 100 times smaller than any bacteria on Earth. And there does seem to be a minimum size for life because, as we talked about, you need certain things in life, which puts a lower limit at their size. So still controversial, but probably not. But it was certainly, it's really got kick-started astrobiology, the search for what life needs and where we might find it out in the universe. So I'll also have, which I'll send to Rob and he can distribute, I also have asteroid, 3D asteroids you can put together. I'll send them along. And I have projects about how you can collect your own iron meteorites on Earth. It's not really as hard as you may think. And so that's just a little bit introduction about the meteorites that are in our collection. Are there any other questions?
I was just curious about your first slides with the maps, and it was showing where all the different meteorites and things were found.
Yep.
It seemed that there was a lot in North America for whatever reason. Is that just the samples that were given in this, or are there more found in North America because there's more people lurking, or?
No, this is just looking at all over the world.
Okay.
Most meteors are found in, like you say, the desert areas,
Right,
or Antarctica. These might be more plentiful because people have actually witnessed them fall, and so being able to go out and look for them. But this is just an overall look at where the meteorites that came from.
right.
I was reading an article in one of the magazine that I get, and it was talking about like all the little ones that there's this one guy and he goes around and he searches in like eaves troughs.
Yes, well, that's exactly the method I was going to send out. You can collect the rainwater off the eaves troughs. About 1% of the dust and dirt that we find all around us are actually meteorites. So you collect the water, you put it through fine filters, and then you use a magnet to collect the meteorites. So I will send that information on, and maybe some people can try that.
Yeah, that's super cool. And yeah, and to look at some of those the things that the guy found under a microscope, I mean, they're just beautiful, weird little rocks. That's
the problem. You have to use a microscope to sort them out in the end, but you can collect them.
Cool. And then we've talked before about you know, being able to predict you know, when you know, some of these larger masses are going to be going by Earth.
Yes.
Where are we with that? Do we how skilled are we at being able to track these things? Do we
Certainly the search is on to identify all NEOs, which are near Earth objects. These are ones that might have a trajectory that could one day hit Earth. There are wide field surveys doing that, studying that. So we are getting to locate the larger objects. Again, Chelyabinsk, that was about 20 meters. We didn't see it coming because it came out of the sun. We had no idea it was coming. That same day, we were actually watching for a much larger asteroid. I believe it was about 100 meters diameter, that was going to come within 28,000 kilometers of the Earth. That's the one we were watching. We knew it would not hit, but we wanted to see it. I mean, at 28,000 kilometers, that's the area where some of these synchronous satellites are. Not that it was probably in danger of hitting anything like that. So we're really watching this one, waiting for this one to come through, see what happened, and this other one came out of the sun and sun's direction and you know, rained down on Russia. There are no NEOs that have been found that are whose orbits would make us think they will be hitting Earth anytime soon, and that means probably hundreds of years. But again, if the Chelyabinsk, instead of skimming the surface of the atmosphere, if it had been come anytime and gone right through the atmosphere to the Earth, it could have been devastating to that area. And there's probably only been one person ever killed by a meteorite, and that one's under dispute too. So some have fallen in dented cars, and some have fallen right through roofs, but no great injuries have happened. And if, you know, so many fall on Earth every day, but if you look at the Earth, 70% is oceans, so that's where most of them are going to fall. Anything that doesn't fall in the ocean, it's most likely to fall in Russia, because that's the biggest area too. So unpopulated, mostly not seen. So most of the stuff we don't even see come.
How valuable are meteorites? I know I got one a while ago. Like I got it from at the shop, and then I was listening to this podcast, and they're talking about how much meteorites are counterfeited.
Yeah,
The whole
because
market, like, and knowing whether or not you got the whether or not you have something that's
exactly you need
legit at all. But so it's obviously a big market, and there's people that are really into the trading and the buying and the selling of it.
Yeah, there are reputable dealers, and there are people who will sell you nothing. So just an example. So this one we looked at, this is that iron meteorite. This is called a lodestone. So we saw that the iron meteorite, very magnetic. This is a lodestone. This is iron from Earth, and it's also very magnetic. So you really need to know secondary characteristics. You need to know the internal structure. You need to know where it was found, and you need to have it looked at by certainly a professional to confirm that that's exactly what it is.
Now, how would they? You mentioned before some of the way the material was structured.
Yes.
Right, because it was in a different place. Now, would they have to? Would some of these to actually figure it out? Would they have to look at it under like an electron microscope, or?
Sometimes, yes.
Yeah.
Yeah. Or polarizing light that we saw. The Mars rock had some polarized studies doing. So yeah, you just can't look at it. You look at its shape, you look at some characteristics on the outside that meteorites have, and then you need to go into the internal structure and do thin slices and look under microscopes.
Now that you had those glass pieces, now those were the pieces that were made from the meteorite hitting the sand and the sand turning into glass. Is that how that works?
Yeah, exactly.
Right.
The size and shape of the meteorite, but it's the speed mostly. So the impacts on Earth are tremendous energy, which melts the silicates and that's mostly what the crust is made out of, silicates, so silicon and oxygen. And when those are thrown up into the atmosphere as lava particles, and they cool into glass.
And what size of a crater would it have to be? Like, I know that like some of the major impacts, they're able to, there's a layer of like iridium around as well. Now, is that something that people go for as well? Is that sought after, or is that common enough that people don't really go search for it?
Now that it's an accepted fact that iridium layer did come from the asteroid that hit Earth 65 million years ago. I believe that's the only iridium layer that has been found, at least. But of course, we have a problem on Earth because we recycle our land masses, and you know, things subduct down and come back up in volcanoes. So we're recycling all the time. So it's hard to go really far back into Earth's history. I haven't heard of another iridium layer, but I have not done extensive studies on that either. Which brings me to a little bit of a thing. When we look up at the moon, we can see how heavily it's cratered. There are over 3 trillion craters on the moon, larger than 1 meter. So you can imagine how much smaller and smaller craters. There are even craters on the moon so that when the silicates are heated and molten and they condense back into glass, on the moon they can condense into microscopic spheres of glass, and even those have craters on them. So numerous craters on the moon. The Earth is a bigger target, so we would have been hit many more times, and yet we can only find about 170 actual craters on the moon, on the Earth. So what are your ideas about why we just don't find them on the Earth? I've mentioned one.
Ooh.
Oh, yes.
I think it's the water.
Exactly. Most of them fall into the water. Yeah, or Siberia. Yes. We also have an atmosphere, so a lot of them will burn up and not even reach the Earth. And again, it's that recycling of the Earth's crust material that, you know, takes these craters underneath, subducts them underneath the other plates. Volcanoes can cover them up, and the erosion through wind and water certainly erases a lot of the craters that have formed on Earth. So we do find some, but not that many, like say only 170. Does anyone know what Sudbury, Ontario is famous for? It's famous for iron mining. And that is because it was hit by a large iron meteorite. I don't know the date, millions of years ago, possibly. And so all of that is being mined now.
So like, so it would have hit millions and millions of years ago, and it wouldn't be all one big chunk still.
No, it's mined. So
It got put there, and then it just kind of has been over time has been distributed out.
Distributed and mixed in with the Earth. Yeah.
Interesting.
Yeah.
Well, Zach, what did you think, buddy? What was your kind of takeaway? What was something that you thought was pretty neat?
Oh, well, I don't know. There's like a lot of like really interesting stuff that is going on.
I kind of put you on the spot there, buddy. No, but totally. Lots of. I had no idea that there was so many different types. But it totally makes sense that, you know, you think about all the different types of rock here on Earth, that of course there would be all kinds of different types of rocks floating around out in space.
Exactly. Yeah.
Jason, what was your takeaway?
Me?
Yeah. Any thoughts, Jace?
Well, with space, there's so much that we don't know, even if we think we know more than we do know. So this could just be a tiny section of all the meteorites we've ever found. There could be countless other types of meteorites.
You're exactly right there. the types of meteorites are almost endless. I think it's amazing that we can actually trace them back. Some of them we can trace them back to the family of asteroids that it came from because we've been remotely observing asteroids. We've been doing spectroscopy on asteroids, so we know what they're made of. This also leads to studying what we can do if we do see an asteroid heading straight to Earth. We need to know what it is made of, because if it's a large stony asteroid that's almost fluffy and that the gravity isn't holding things too much, if you send a bomb to it, it's just going to probably, go right through. Nothing, it won't disturb the asteroid too much. Whether if you have a large iron asteroid coming towards you, so the very massive at the speeds would cause a lot of damage to Earth. You send something to explode it, and instead of one object coming, they've got maybe several million objects coming at the same speed, and so you're spreading out the damage, which might be even worse. So we need to know what's out there to know how to mitigate any damage from them.
We need to know where we can send Bruce Willis, right?
Yeah, don't get me started.
Brent, how about you? What was your takeaway, buddy?
Well, the whole thing was really interesting. The piece that really jumped out at me towards the end there was that we only know about 170 craters. That baffles my mind. I thought for sure that, I mean, it's easily explained, I guess, but I would have thought for sure that there were many more that were known.
Yeah.
Yeah, but I guess just with most of the Earth being covered in water, that's where they're hitting.
That's a lot of it. Yeah.
And I guess like trees and leaves and things growing and dying, right? Just cover things up so quick.
Yeah, the erosion, water erosion, wind erosion, just wears away.
Caleb, what was your takeaway, buddy?
I really liked it. I didn't know there were 107 craters. Well, I knew, but we knew a lot more or a lot less. And yeah, and I was mostly focused on the mouse that I was trying to save.
Will?
The most meteor.
The mouse meteor, yeah. It's got a long tail on that one. It might be a comet.
Yeah, maybe a comet.
Yeah, I learned a lot from that. Yeah, because I did do research on the Chelyabinsk one. So yeah, but like that's crazy that there's still a whole bunch out there that still haven't found, and there's still stuff like it does make sense that there's more out there because we just haven't explored that much. Like we've explored a lot, but like there's just more and more and more that we still haven't found because like everywhere, especially on the Earth, they erode away and you never can really find them in time. Yeah, so it is pretty neat.
I think Will, what do you think about the idea of us going around in gutters next year and seeing if we can find some meteorites? I think it's good. Wyatt, what was your takeaway?
I liked the whole thing. It was extremely interesting. The whole thing blew my mind. I didn't say that. I just want to say that. I extremely liked it. Keep up the good work.
Thank you.
I was also quite surprised that we have essentially meteors from different planets and from the moon and stuff. That I never thought about that either, that when they get hit, that stuff gets ejected off of them and then can in turn become the meteor hitting us.
Mm-hmm.
And
which also means there could be Earth meteorites on the moon and Mars.
Right.
Whoa.
Yeah.
Which will totally mess up research when they discover that, and then.
Yeah.
Yes.
Well, that was great, Colleen. Thank you so much for once again melting our minds a little bit. And yeah, that was.
I have something to show you.
I actually thought I knew a little bit about meteorites, and it turns out I didn't.
I find that about everything I study in astronomy.
Yeah.
I found something very